Okay, so this is the title of the presentation, what we're going to be covering. Basically transmission lines, and then Brian has great practical information at the end and demos and all of that. So I'm really excited to have that as well in this webinar. So again, why uniform impedance is crucial for transmission lines. So inconsistent line impedances cause signal reflections and EMI, all which are not good. So getting this right really will make an impact on you and your what your company is trying to do. And of course, high-speed signals are critical, and they need proper timing. And when you have a good impedance, you'll get consistent signal travel, preventing your synchronization errors. And the impedance mismatches can also cause power losses. So you'll improve your power efficiency and basically better health overall for your PDN. And so Sierra is going to try and do more webinars on PDN, because that's becoming a very important topic for lots and lots of engineers.
Yes, we'll be doing a webinar on PDN with Steve Sandler in Q2.
Thanks. So that's great. So good to hear. So, this is why control impedance is, so super important. Some interesting facts, which I'm going to skip over. And then, just the idea of showcasing the structures, microstrip, strip line, coplanar. So this is a reference of what we're, speaking about, in different structures you can have. So you want to look at your signal speed and propagation delay. And in microstrips, the signal trace will run along the top surface of the substrate, and the ground plane is on the bottom. So the signal partially propagates through the dielectric, so resulting in a lower effective dielectric constant compared to other geometries. So microstrip lines generally have a higher signal speed and a slower propagation delay. And for the same trace width and spacing, you need to have slightly lower signal speeds and greater propagation delays. And in the strip line configuration, the signal travels.
Just, Amit, on the microstrip, the signal is on the outer layer, and the ground plane is just the layer next to that. Okay, not at the bottom. Okay, yeah. I just wanted to make sure.
Okay, thanks.
Yeah.
Here's a chart which shows the dielectric constant, effective dielectric constant, signal speeds, propagation delays in these different structures, microstrip and strip line, for a few different materials. And these materials are very commonly used at Sierra, and I think around the world, really. Next, we talk about this concept of critical length. So the trace length, the critical length is the trace length above which the trace has to be designed as a transmission line with control impedance. So you can use these formulas to understand what is the critical length for analog and digital signals. And so the idea is that, when does this become critical? You should know. The short lines may not be critical. Next is signal rise time. You need to know the data transfer rate and the clock frequency to calculate the signal rise time. And so you can compute the signal rise time with these formulas. We have a better way to do this, and I think we're going to do a demo for that. Is there someone to do the demo?
Yes, sir.
Okay, thanks.
Hi everyone. Uh, so this is a Sierra Circuit's bandwidth rise time and critical length calculator. This helps you to calculate the signal wavelength and most importantly the critical length or the short length of the selected geometry. So we have three types of geometry over here in the drop down: the uncoated microstrip, coated microstrip, and the strip line. Let's go with coated microstrip for now, and you can see that the representation of the geometry image has been changed accordingly. Let's enter the input parameters. Let's go with a dielectric constant of 4. And then we have maximum data transfer rate, faster signal rise time, maximum frequency content, and the 3 dB bandwidth over here. And you can choose any one of these 4 parameters as your input parameter, and the other 3 will be calculated. Let's go with maximum frequency content for now. And to choose that, you just click on this tick box here. And you can enter the value. Let's go with 10 gigahertz and click on calculate. The DTR, fastest signal rise time, and the 3 dB bandwidth are calculated and displayed over here, along with the wavelength, critical length, and the maximum short length. So